Hello, everyone. Thank you and welcome to GroupBy. Our next session is automating the pain away with SQL Server 2019 with John Sterrett. John is the CEO of ProcureSQL and a performance tuning and scalability expert. Take it away, John.
Nice. Thank you for that great introduction. So what are we covering here in the next hour? We're basically going to go over some of the super cool new stuff that helps your queries run faster without you changing any of your code. So this started really in 2017. I would say 16 because QueryStore is a tool that's used that a lot of features sit on top of to help make performance better. But we're going to go over exactly what is QueryStore briefly. Also, how do we use it to make good decisions, or better yet, how can SQL Server 2017 start to use this on its own to make performance better by doing plan guide reforcing? So this is what I refer to as you redo your index maintenance, or middle of the night, a plan pops out, a different plan comes in for your statement, and you start to see worse performance. This demo is going to show you that and how auto-tuning should go through and help fix that for you in a lot of cases. Next, we're going to go into something that doesn't automatically make your code change, but I think it's one of the best new tools in your performance tuning tool belt. And this is actually being able to get weight stats all the way down to an execution plan inside a QueryStore. And I'm presenting it here to you now because if you download the latest RC version of Management Studio right now, you can actually get a free dashboard report that's baked in there already free to use that kind of looks to what I used to see way back in the day by Confio, and they had a tool called Ignite. It looks somewhat similar to that. It's a really great way to figure out why your queries are not running as normal and what is causing them to be slow. So from there, we're going to go ahead and dive into intelligent QP, query processing, also known as IQP. So this is where some new stuff in 2019, like scalar functions not sucking anymore and being able to do set-based logic instead of row-by-row processing. Table variable deferred compilation. So one thing most people know, when you work with table variables, it's always going to assume one row. Well, this starts to change for you by default. We're going to go over that as well. And then we're going to talk about adaptive query processing. This was added in SQL Server 2017. But there's three main new things here to help make your code go faster, whether it's adaptive join types, automatically detecting whether I should either do a nested loop or a hash join, interleaved executions with multi-statement table value functions, and memory grants. So, and the reason why we have the last bulletin code for batch mode to row store is because now you can start to use some of those AQP stuff without having to be in batch mode. So, I know we went through a lot. So we're going to go through the real raw basic, the one thing you really have to know to get a good understanding of where we're going in this presentation. And this really is just the life of an execution plan. So with that up here, we have some basic questions. So I'm going to zoom in a little bit. We have a T-SQL statement that you're running. Now, if this is the very first time you're running it, you're not going to have an execution plan in cache or in memory that can be reused. So if you did, then it would just use it, right? But the big question is, well, what happens if we're in a scenario over here where we don't? And what happens there is we're actually going to build the execution plan. But if you have any variables, so like if this is a stored procedure and you're passing in parameters, or you set up parameters for your statement that you're running, it's going to use those variables at runtime the very first time to build that execution plan. Now, in most cases, this is great. It's amazing. It makes us have fast code, and we don't have to spend a lot of CPU cycles rebuilding execution plans. But we'll see when you have a large amount of data skew, and I define data skew as cases where you're going to have a whole bunch of data for different parameters. So if we thought about invoices and customers, right? You're going to have big customers that have a lot of invoices. And then you're going to have smaller customers that maybe just have one or two. Well, the ideal execution plan we would want for hitting an orders table is probably going to be different based off of how much data is in there to use. And so the thing to keep in mind here is when we build this execution plan, it's only going to use those variables that are there at runtime. So when we build that plan, it puts it into cache. So the next time you run the statement, it'll see it's in cache and it can be used. All right, hopefully everyone is with me on that. All right, now we're going to dive into some of the new stuff. So the first thing I want to share, this is a actual scenario with one of my customers. They're a forward-facing website that gets lots and lots of traffic. And we noticed by just turning on automatic tuning, which forced good plans, which we're going to go into in a demo here, alone we saw some really good gains off of this without us having to manually change anything. Us getting to see cases where, you know, a statement averaging 7.2 seconds gets down to 26 milliseconds. So if you want to see more about this, we have the link here, which you can get access to. And with that, we're going to kind of go over QueryStore. QueryStore, if no one's ever heard of it before, it's basically a great monitoring tool that's built inside of SQL Server, starting with 2016 out in the Azure SQL database as well. Now, what surprises me is a lot of customers I meet who are using 2016 or 17, they don't have this turned on. And a lot of times it's just because you don't know it's there or you don't know how to enable it. And in most cases, this is a phenomenal tool that, one, can give you great performance insight into slowly running queries, but also help you in this really hard troubleshooting scenario of multiple different plans and which plan is actually better for your workload and how do you force that plan so it always uses the right plan. And that's where QueryStore comes in. And we'll go into that in a bit here. So showing you with the plan guides here, another nice thing to show here with QueryStore is you can look at the multiple plans. So in this case, we had those two different executions here. We can see plan ID 2392 and 49642 that have various different performances here. So if we're interested, we want to see a lot more, we can actually compare those execution plans on one single screen inside of Management Studio. So this kind of makes tuning a lot easier for people. All right, with that, do we have any questions before we jump into the demos here about QueryStore?
No, I don't see any questions so far, so I think you're good to go.
All right, cool. All right, so we're going to go ahead and jump in. I'm just going to show you how I set this demo up here. So I'm using an old AdventureWorks database here. And let me make sure we have our index here. So we'll get our index in case that's needed for that. All right, and we're going to go ahead and go into our demo. So first we're going to start off, I'm changing the compatibility mode here to 150, aka 2019. Oh, also, by the way, we are using CTP 2.4, which currently is the latest service pack that's out. I'm also using Management Studio 18 RC1, so that way we can go through that demo with the report for the query weight stats in a little bit as well. All right, so we have this enabled. Now I'm going to go ahead and turn on QueryStore here. And notice I have some parameters I'm using here. These are definitely not your default what you'd want to use in a production workload. So I'm going to talk a little bit about these. I basically want to flush this out and do as much short intervals as I possibly can here. So that way we get some more data for our demo here. We don't have a whole lot of time here for that. All right, so I'm going to go ahead and we're going to go through making sure QueryStore, we're going to start off with this being turned off. So we're going to see how does this work today without QueryStore being enabled. All right, first we're going to go ahead and take a look at some data that we're looking at. And you can see, so in this case here, we're going to look at data by territory IDs. And now if the territory ID is 20, this is what I would call a small amount of data. We only have 100 rows we're going to be working with. This is kind of an ideal use case for a nested loop join, which we'll talk about a little bit more here in a bit. Now, the higher case up here, territory number 9, this is going to be where we have over 270,000 rows. So this is where we might hit that tipping point where we might be looking at enough data where a scan might be actually faster than a seek. And that's going to come in handy when we actually look at our execution. So we're going to go ahead and do that. First thing I'm going to do here is I'm going to go ahead and flush out every single execution plan that we have in cache here for our database that we're using here, AdventureWorks 2012. And now I'm going to run that stored procedure here with territory equaling 20. And we're going to see this runs. And here, if we look, we have our 100 rows here. So this is that small case here. So with there only being 100 rows, a nested loop is a good join operator for us. So what this basically means at a very high level, in case no one knows what a nested loop join is, think of this as like your for loop for programming. For every row in here, all 100 rows in here, I'm going to do whatever is underneath here. All right. So the other nice thing, if anyone's ever had an interview and someone's asked you, how do you look at an execution plan, left to right or right to left? It's kind of a setup question because you get a lot of great information going both ways. So I mentioned that because I want to go to the properties here because on the slide where we talked about an execution plan and how it's built, I want to show you the parameter list here. And over here, we are actually going to see that when we compiled this plan, it was the very first time we ran it. So we used the value of 20. And now this is the first time we ran it. So obviously our runtime value will be exactly the same as the value that was compiled. So this is our ideal execution plan for a small set of data for this query. All right, now I'm going to go ahead and I'm going to throw out my plans for this database. They're all going to be gone. So when I run this stored procedure now for 9, which is our big set of data, we're going to see it's going to use the value 9 to build the execution plan. And in this example I mocked up, it's this way for a reason because we're going to see quite a bit of a different execution plan here. So for example here, we are actually going to read all the rows. We've hit what's known as the tipping point, and the optimizer believes it's better for us to actually do a scan here instead of doing that nested for loop over 1,000,000 times here. So once again here, if we go over here to the properties and we go look at our parameters, same thing, we're going to see that our compiled value is 9 and our runtime is 9 because remember, we just threw out our plan cache and we had to build this all over. All right, hopefully everyone there is still with me. And now we're going to go into more of a real world. So this is like ideal use case, right? We have 2 different sets of data, and every time we run that, we're going to use the plan that's best for both sets of data. That's not how the real world is going to work for you. So I'm going to run this stored procedure that's going to throw everything away. And then we're going to run that same stored procedure with the big data set 30 times. So as this is loading, we're seeing the plan come in, we're seeing it run, it's going to go ahead and do its thing. It should take about 20 seconds or so for this thing to complete. All right, so 12 seconds there. So I like very small, simple math. So we're going to say we ran it 30 times. It took 12 seconds to run. We're just going to call it, half a second in execution. All right, so keep in mind that with the plan for territory 9, which would be our big set of data, doing the scan, it actually took us half a second per execution. So now what I'm going to do is I'm going to simulate the real world. Maybe we built an index where the plan just fell out of cache, and we're going to build the execution plan with territory 20, which is our small set of data here. So our nested loop, remember, so this is ideal for a small amount of rows to process here. Now we're going to go back and run our big guy again. And the first thing you should notice here is we have some things that would jump at me when I would look at them. So big fat lines here. I never really want to see a big fat line like this going into a nested loop over here. Because this is telling you that for 273,000 times, we're doing that for each loop, looping through and kind of going through here and doing what else is needed underneath here. So we see that this query took 20 seconds to run, and we ran it 20 times. So in this scenario, this runs twice as worse as our ideal use case. So the whole goal here of automatic tuning using the force good plan is for us to be able to see the difference there and to be able to use the best plan for us. All right. So if I set up this demo and everything is working right for us and the demo gods don't bite us here, even though I don't have query store enabled, I should be able to run this block of code and see some recommendations. And it looks like that's not happening here. Well, what this query was supposed to show you was similar to exactly what we saw on the PowerPoint here. So I'm going to go back over to the PowerPoint here.
Do you have Query Store on? Because a moment ago you said you didn't need Query Store, but your comment saying you need Query Store but not automatic tuning.
No, automatic tuning. So here we have automatic tuning off. Query Store should be on.
Okay.
Right. They should be able to. So if we go here and we're on
2012. Yep.
Yeah, and I go down in here to Query Store, and if I looked at regressed queries, so we should start to see our queries in here. So let me make sure we have Query Store on. I'll tell you what, we'll run through this one more time here real quickly just to make sure. So yeah, this is turning automatic tuning off, but Query Store is on.
Gotcha.
And we've already gone through all this. So I want to go through and show you this here. So if we run this, then we should see our, I don't want regressed, I want top resource consuming queries. So here's the example that we would look for. And this is anyone who hasn't seen Query Store before. You see we got one major statement here, but two very different executions. So if you wanted to, you can quickly go here. We can compare the plans, and you can go ahead and look and see the difference over there. All right, so we have that there. Let me minimize that. There it is. All right, so going back over here, we'll do this one more time here by saying execute and initialize there. That should take about 12 seconds or so. All right, so 13 seconds, that's done. We're going to go ahead and, I don't know what this may be. No, we're going to go ahead and clear out our execution plan here for our database. See that we execute this once and it changes. Back to our nested loop. So now we're going to use the nested loop with the several amounts of data here. And as this is running, should be able to refresh this guy. And see some more data points there as that's going. So Query Store would allow you to be able to catch this data and make some good decisions on it. Also, with configure, here you can change your time intervals as well. So if you wanted to go ahead and change that, you can. The big thing here is forcing the right one. So in 2016, if we saw this and we said, hey, we want to lock this guy in, we'd click on him and you'd click force plan over here. The whole goal of the automatic tuning's force good used plan is that it will actually make these decisions for you and be able to revert them as well. So, all right, so we have this done here. So now, once we got something jumping up at us, this should give us some data. Nope. All right, so we may actually have a broken demo here. We'll run it one last time here with Query Store turned on to see if the whole goal here is when we're running the statements over and over again, we should see that the execution plan automatically changes for us.
It was complaining about a semicolon there when you ran it.
Okay. Not sure why. Well, if you want to see that Query Store or
Oh, I think it's because you have a begin and an end and you're running to the middle of it.
Oh, gotcha. Thank you.
Yep.
Eugene. So here's looking, and here you can see, do we have the automatic tuning enabled? In this case, we have, because we turned it on right here by saying forced last good plan. So in 2019, you can actually also use this for cursors as well. So if you're not using fast forward cursors, that's another option that you can look into. So with this now, we're going to go ahead and try this one more time over here. So once again, we have our executions with our scan here because we reached that tipping point. And then once that finishes, we'll go ahead and get our plan for our small set and then rerun the big data here. So I'm going to do that. Where we have our nested loop. And here we're going to go in. And so if this works, what we should see eventually is this will flip back over to that scan. There we go.
Nice.
All right, so looking at the demo data didn't work, but where we were trying to go does work here.
Right.
So it's the fun with working also with CTPs. And this also is kind of a little bit of a hard demo to drive home with the right exact data set that will force an automatic plan change for you. But regardless, here you can see that while we were running this, we flipped on over here. So without us changing anything, Query Store was able to detect with automatic tuning that there's another plan that's better. Why don't we try that one? And so that's exactly what happened here. And so this took 17 seconds. So remember, the first time, about half a second. Second time, it took a full second per execution. And now we're a lot more closer towards the half second here because it was able to change. So if we go down here, we can go ahead and review our information here. And this will tell you the status there and exactly what all happened between the differences there. The nice thing here is this will also get you how it ran, how many times it executed in each mode, and if it needed to revert. So all that information is there for you as well. All right, so I'm going to go ahead and turn this off because I don't want this to mess up any of my other future demos. And any questions at all about kind of going over Query Store and how automatic plan use works?
So I think everyone's following along. There were two questions that came up. Peter Schott had a question about, you know, which of these changes require 2019 compatibility mode, or can he run a database in an older compatibility mode and still get some of these benefits?
So great question. This is a feature actually in 2017. So if you have 2017, then you can do the plan guide reuse in there. But 17 or 19 will work with that.
Yeah, and then another question, Viorel Siuku, feel free to correct me on how I got the name is, was curious about if you had any experiences with Query Store enabled and failing over with an always-on availability group whenever there's a lot of activity. The issue that he or she ran into was that there was some glitch or some issue with how quickly Query Store was persisting that data, and so the failover took much longer because I guess it was waiting.
Yeah, so I submitted a session to pass that goes over Query Store in a lot of details, and because we only have a small amount of time, I can't go into all of that here.
Sure.
But yeah, there's actually trace flags that you can use that disable the fact of waiting on Query Store to go through the crash recovery process.
Nice.
And that trace flag can be very helpful for you.
Very cool.
Yeah, I'll throw it in a channel later after the presentation.
Yeah, but that's it. So go ahead and keep rolling.
Cool. All right, so now we're going to go to the wait stats, which is, I think, a really cool, helpful feature for troubleshooting here. So I'm just going to throw everything out. So we can see we don't have any wait stats. We just have the statements as we're building them here. And we're going to go ahead and run some queries to generate some waits. So I threw everything in a trash, everything being our data pages. So we have to read them from disk instead of memory. And same thing for execution plans here. And I'm going to run the select star across this big table. Only purpose here is to generate some disk wait resources here. All right, after that, I'm going to go ahead and do this select star off a customer. So give me all the data for this one single customer. So we saw that ran sub-second, returned 102 rows. Now I'm going to create what is a very classic example of blocking here. And what I'm going to do here is I'm going to update in an explicit transaction. I'm going to set the delivery instructions to an error. And so while this query ran real quick, if I want to select, you see here, this query is waiting for that update to finish. No matter what I do in this query, it's just going to sit and wait and wait and wait until we either commit or roll back this guy here. So we see this guy is still running. If I come back over here and roll him back, I'm going to try to do some quick magic here. So execute, hop, you'll see it instantly finished. So this is just your trademark blocking example where one query was running. If you've ever seen like an open tran and you wonder why something's blocked and not finishing, this could be an example of that. All right, so we have our query finished there. Now we're going to actually go into Query Store and look at some of this wait information. So we're going to pop it over here. Now I'm going to want to look at all the queries that have that table we're looking at inside of Query Store here. And so here you'll see that we have our select everything, which we did for our disk weights, our select from our customer ID in here, and then that select count. Now you do not see the update because we rolled it back. So keep that in mind that you may not see every query that runs because we had an example of one rolling back and it not being in there. So with this, we know the query that we're really going to want to focus on here is our one that got blocked, which is 9. So we're going to go here, change our ID, and we're going to go ahead and look at the plan info. So you get all kinds of great information. If anyone does an upgrade, you have the edition versions here, so you can use this as a tool to see if plans reverted after your upgrade. And of course, we have our XML, which we're going to look into later. So the next thing we're going to do is we're going to go ahead and look at this new DMV inside of SQL Server 2017 called Query Wait Stats. So I'm going to do that with looking at our interval. And the reason why is because for the demo, I set the interval to collect every single minute. So all of our metrics that we see are going to be bound by that begin and end time. So in the real world, you're probably not going to use a minute here. But the nice thing to know about Wait Stats DMV for Query Store is we have a unique identifier. We have our execution plan. We have our runtime interval. So we know that this ran during this minute here. What category of our wait here? And then, of course, how long? So pretty useful, great stuff that you can aggregate to figure out when someone calls you and says, you know, on Tuesday at 2 o'clock, our report was really slow. Well, you can go back in here and look and see, okay, well, you know, we had a big issue with disk access and it was waiting on disk access, and that's our reason. Or whatever it might be for you. So with that, also, if you wanted to, you can easily just aggregate it all up. So here's just an example of aggregating, getting every single wait type for the one query I want to focus on. So this is all great, and you can do so much amazing, cool stuff with this. What I want to focus on is this guy. So the reason why we're talking about this with new cool stuff is the fact that we now have a report inside of Management Studio 18 RC1 that's going to allow us to look at our statements driving wait stats. So things that waited a long period of time from executing to executing again, you can figure out what resources caused the majority of that. So for example here, we could even drill deeper. So this is where I talk about, if anyone's used the good old Ignite by Confio tool, we looked at a wait stat for a time interval. So we can easily change our time intervals again by specifying what kind of time interval we want. Remember, this is just going to aggregate against those intervals that you set up for Query Store and its options for when it's going to actually compare data, which we did a minute for this demo. But the cool thing here is now that we went to network and we know we're having some network issues and we may want to talk to our networking team, or maybe not because the code might not be efficient, we can look here and see that we have 3 different statements, and this single statement here is our top offender that we'll want to look at, where we can go ahead and look at some other ones in there as well. So really cool how you can go all the way down to a query or the execution plans, meaning one or many plans for a query, and figure out what resources were causing the waits for a given period of time. So I hope that's something everyone's able to use as part of their great troubleshooting skills, because I think it's a very nice tool that I've already added to my tool belt. All right, with that, we're going to go back to our little dashboard here. All right, now for the rest of our session here, we're going to talk a little bit about intelligent QP, also known as IQP. And I think this graphic from Microsoft Docs website does the best job of saying, okay, what's in 17? What's in 19? What's even there, right? So we're going to talk about a couple of these. For example, scalar UDF inlining. If anyone's heard of scalar functions and why you probably don't like them because they cause row by row processing, you'll see that in 19, the optimizer is going to actually see this and turn it into set-based logic for you. Also, we have table variable deferred compilation. What this means is if you've ever used a table variable, you're going to know that one of the biggest cons against it is it's always going to assume one row. Well, that's going to change in 19 as well, as we'll show you here. And then, of course, we'll also have all the good old adaptive QP stuff, like the adaptive joins, the interleaved executions. In 17, so these are really only for Columnstore because you had to be in batch mode. The cool thing to know about SQL Server 2019 is you can now use row store, or you can now use batch for row store. So you can start to see some of these coming into your non-Columnstore indexed tables. All right. So with that, we're going to go straight into common problem with table variables. There's quite a few, but a really big one that jumps and bites everyone in the butt at least one or a dozen times is the example shown here on the left. So you see that we're using a table variable, and it's assumed only one single row. And because of that, you usually are going to get an execution plan built off of that one single row. And it's going to hurt things downstream. So as you go and join other tables, you might see the not most best operator for you in joining that data. Also, you can see cases where if you have to do any sorts, it might just pull the data out to tempdb because the plan didn't reserve enough memory for you because it assumed only one single row. All right, now on the right, this is what we're going to see by default. So if you have 2019 and you're in cardinality mode 150, you're going to see that the execution plan is actually going to stop, say, hey, this is a table variable. Well, let's stop, use real stats, get stats, and use those. And so here's an example where you see not only you have really good stats, but you see the operator actually changes as well. So it's going to use a better operator to join and do that downstream as well. So with that, how would we fix this before? So if you're not on 2019, you got a couple options. Option recompile you can use, and that will go ahead and force stats as it's going to build the plan at runtime. There's a lot of CPU overhead for this, so maybe not your best option. You could always use temporary tables, and then there's also a trace flag. The main thing we're showing you today, though, you don't have to do anything with 2019. It's going to do all this for you. So let's go ahead and take a look at that. Okay, so here we're going to go recent files. All right, so here is our example, and we're going to do the little before, then the after. So this is before 2019. And if we go here, and all I'm doing is just grabbing some data into a table variable, and then I'm joining and filtering off of it. So we're going to want to focus on our second execution plan over here. As you can see, it's going to take a little while to run. Got a few seconds over there. Oh, helps if I include the execution plan. So the whole point that we're going to see in the execution plan here is that we have only one single row assumed here. So even though we're actually hitting 3,806 rows, we only are estimating one single row. So here we're using a hash match. Now, all I'm going to do here is I'm just turning on 2019 compatibility mode. And we're going to run the exact same statement. So we haven't changed any code. No code has been changed. There's no rabbit up my sleeves. I did short sleeves, just to make sure they were not hidden under my long sleeves if I was wearing a long sleeve shirt. Anyway, here we see, if you look, we are actually paused, got good stats, and are using it. And because we're doing that, we've even changed our operator. In this case here, we can use a merge join, which is better for our execution. So that's just one of the great new things with 2019. So without you changing any single bit of code, you're going to go ahead here and see that with using this wonderful feature, it's going to go ahead and get you accurate stats. Use those so that way it could persist downhill for all the other joins that you have. Pretty cool stuff, I think. So with that, we're going to go ahead, go back to the slide deck here. There it is. All right, now we're gonna look at the other super cool feature here in 2019. And this is scalar functions and going away from the row by row processing. I always kind of refer to this as the silent performance killer. And that's mainly just because there's a lot of information you're used to seeing, you're not gonna see inside of an execution of a scalar function. So like if you look at the execution plan or set statistics, you're going to notice that that information is not going to be around. So let's go ahead and get that going here. I'm going to go to my demos, my scalar. All right. So with this here, we're going to go ahead and go to our 2012 here. I'm going to show you the old mode here. I want to get this SPID here, so that way, the only real good way how you can detect a scalar function being used is either through extended event or a table variable. So in this case, I'm going to go ahead, we're going to set up a quick trace here, just using the tuning template. And we're going to see that while we don't actually see this in our set statistics or our execution, we're going to go ahead and see it in here. So 75 is our session. Go ahead and get that running, have that running. All right. And here we are. All right, so I'm going to turn on my set statistics here so we get that. We're going to have our execution plan. And with this, we're going to go ahead and create our basic scalar function here. So if any of our functions exist, we're going to throw them away. And basically here, all I'm doing is a quick aggregate. Give me a product ID and I want to know the max amount of quantity for orders for that product. Nothing super fancy. We're going to start our troubleshooting here by throwing everything else into the trash can. So we start from nothing in memory. And then I'm going to go ahead and run this statement. And we're going to see this is going to sit there for a while. But the interesting thing here is, see this scalar function here? Every single row we have inside of the table that we're pumping through the scalar function, even though we're not filtering, right? This is just in the select part. It's going to cause us to take every row, use the function for that row, and get an output. So this is kind of a big pain in the butt that most people don't see or even know about. And the nice thing about 2019, this will fix itself for you. So if we just look here without knowing we have a scalar function, you're probably going to be confused because all we see is the product table. We don't see the table in our scalar function. We see we did 4 logical reads and we're sitting there waiting for 27 seconds. This doesn't make a whole lot of sense. We look at our execution plan, we're going to see the same thing. We're scanning across this one table. We don't have anything at all for our sales order and large table at all. Let's go ahead and turn on 2015 now. I'm sorry, 2019 using compatibility mode 150. We're going to clear everything out. And we're going to run that exact same query over here. And this time, we're going to see it's going to be a bit different. So we noticed when we ran this before, it finished over here. It took about 27 seconds in this example. When this time it runs, notice we don't see any row by row processing here. We don't see us running through the gamut of going through and doing row by row processing. So this guy, when he finishes over here, there we go. We're going to see we actually have all of our data in here. So this is just like if we ran the same code with a table variable, or a table variable instead of a scalar one here. So we actually see that we're scanning across our very large table here and doing a bunch of other stuff we see in our execution plan. We actually see it here in our set statistics as well. And the big thing to note here is this is it for this running. It's just the one statement. We're not doing row by row processing. You can see. So really, really super cool stuff there. Eugene, how are you doing on time?
Yeah, so you've got about 16 minutes, so you're doing pretty good.
Oh, okay. Sweet. All right, so now we're going to bounce back over to... Oh, did we have any questions that popped up as well? Eugene?
Yeah. Good call. Just the one, Ricardo was asking about kind of what's the overhead on Query Store, enabling that feature.
So it's a great question. The overhead is determined by you because there's a lot of knobs you can turn that's going to control how much impact on performance it would have. So the couple settings I'll just mention real quickly. You don't want it to catch every query, so put it to auto instead of all. That's going to blow up your query store really quick and kind of make it not that useful for you. Also, the default sample sizes are pretty good timing to start for both persisting the data to disk from memory when it collects it and also the sampling. But the main answer there is you control that based on the settings that you change.
Yeah, and VRL said that for his or her system, they collect about 7 gigabytes worth of data in 4 hours, which is pretty crazy.
Yeah. No, I worked with a customer. They're doing a proof of concept with this. They had a 4 terabyte database and had around 500 gigs of query store data.
If I could whistle, I would. Peter Schott's disappointed there isn't like dinosaurs.
Yeah, at that point, there's too much data for it to be really that useful for you to actually read it and get good information out.
Yeah,
so,
that makes sense. All right, very cool.
All right, so going to adaptive or AQP. So this is all stuff that came in 2017. So we're going to go over interleaved execution. And similar to what we saw with variable, we're going to see kind of a similar pattern here where we can interleave through the execution, pause, get better cardinality, and then re-execute. And so with 2017, this happens with what's known as multi-statement table value function. So we'll go over exactly how that works. And this is just a slide telling you that 2017 is just for multi-statement table functions. And it's not going to work for every single one of them. There's a couple of limitations here. I don't know if that's you, Eugene. I have some weird sounds over there.
Yeah, no, I don't think it was me because I was muted. Blythe, you got a car going behind you?
Maybe. Hold on.
I cannot confirm nor deny. She's
I am definitely eating lunch without being on mute. I'm so sorry. I'm so sorry.
She's watching from an Uber right now.
You should have stuck with I ain't saying nothing.
Yeah.
All right, so let's go ahead and take a look at our interleave example here. So we're going to go back to before 2017 here. And for anyone that's not familiar, a multi-statement table value function is very different from a inline table value function. And here's the gist of it. So multi-statement table value function, we're going to specify basically our parameter, like what are we using coming in here? And we can do multiple things with it. So in this example, we're going to select some data. We're going to insert it into this table variable, which is defined in our create statement for the multi-statement table value function. And then we're going to return it here. So an inline table value function is actually different in the fact that we don't define it. We're just saying it's going to return, we're doing one single thing. We're getting that data and we're returning it. So inline table function here, single select that's being returned. So me, even in my old developer ways, like I would think the top one would be much better because, hey, at least we're defining what we're getting and using. But we're going to see actually the opposite here. So we're going to go ahead and turn on our execution plan, and I'm going to go ahead and turn on our statistics. And we're going to go ahead and take a look at these. So the only difference between the queries we're running is whether we're using the multi-statement table value function or the inline table value function. In reality, they're going to do the same thing, get you the same data. So we got our execution plan on, and we're going to notice some pretty cool, interesting stuff with this. Takes a little while for run, about 6 seconds. All right, so we're going to go over here, and I want to go ahead and we're going to see when we look right over here. So we have 231,000 rows that we're using, but because we're using 2016 compatibility mode, we have 100 rows estimated. So this is similar to the table variable, where we just have this fixed baked number. It's not really anywhere near what we're using, so we're going to use a wrong operator. In this case, that nested loop. Remember, this is just your for loop. For everything over here, we're going to go ahead and seek down here. But wait, there's more. There's more to why this plan is bad. We have this sort over here, and because we estimated at the start to only have 100 rows, we got a real small amount of memory to work with. So we actually do our sort over here. We're going to spill into 10 dB. So here you can see in the warning message, we actually have over 5,000 pages that are needed, but the plan only gave us 1 MB of memory to use here, which is why we're flushing out the 10 dB. Also to note, when we look at the memory that's granted here, we just have that 1 MB here, which is nowhere near enough to work with this actual plan with the data that's coming through. So let's look and see, well, how would this be different, John, if I just used an inline table value function? So this is for everyone who's not on 19. If you want to see how do we detect this bad pattern and how do we replace it, if you can, it's as simple as just using an inline table value function instead. So 6 seconds instantly, right? One's obviously a little bit better. Let's go ahead and take a look why. So one, we are not using that nested loop because we have this thing called statistics that are useful, and we actually are estimating and using 73,000 rows in our estimate. So because of that, we go through, we do our hash here. We see we don't have to do our sort and flush into 10 dB. And you'll see under the memory grant here, we actually have roughly around 23 MB instead of 1. So a much better execution plan for us. All right. So now we know the before and the after. Let's go take a quick look at what this would look like in 2019 or 2017 here. So we're going to go ahead, throw everything out, start brand new, and I'm going to run that same multi-statement table value function. So this is going to go ahead. And you see this looks a lot more like what we saw with an inline table value function. And that's because we were able to stop here, get a better estimate of rows being used, coming in through our statement here, ended up not doing a nested loop join and actually a better join for our operator over here. And because of that, we could see that we got a much better memory grant over here. So if we looked at our benchmarking here, we saw that roughly around 500 IOs in 2.3 seconds here. Of course, you can still do this in 2019 with an inline table value function, in case anyone was interested. And nice thing here, we're going to see a very different thing with our execution plan we're about to talk about. But the whole point before we get to that is much less IO and even faster. So if you're thinking, well, 2019, I don't have to rewrite anything, that may or may not be true, right? You're going to see some better performance in a lot of cases because it's using these new features. But also, there's still opportunity if you're able to rewrite them to get better gain if you're looking for every single inch of performance you can get. So with that, we'll go back over to the execution plan. If anyone's ever looked at execution plans before and you see a join, you usually see two things. You see 2 tables coming in, 1 going out, right? We see this with the hash match up here. So if we look, we have a scan across the people table getting a little over 1,000 rows. Then we also have data coming in from other tables that hash match, and then data comes out of it. Well, if we look over here, we're going to have what we call an adaptive join. And this is a scenario where we kind of have a variable. We're in a hodgepodge of maybe it's better to use a nested loop, or maybe it's better to use a hash join. And we're actually going to use data here to figure that out. So we're going to talk about this a bit more in another demo, but in a nutshell here, there's a row threshold built off your statistics. Now, if you're going to use more rows than that threshold coming in, it's going to use the hash match. If it's lower than that, it's going to actually use the nested loop. So in this case here, our threshold rows is 13. Our actual number of rows is well over that. So because of that, we're going to do our hash match and our scan here. Where you see if we go down here, the seek has 0. If we were going to use the nested loop, it would seek off of it instead. So we're going to talk a little bit about that, adaptive joins here in a second. But that's just a nice little tease to get into it. That we'll go to our PowerPoint here. So adaptive joins, right? This is just in a nutshell what I just showed you in detail here, right? So we have a threshold, right? In a way, I kind of look at this as the parallelism, right? You have a cost threshold for parallelism. If you're above that, then you can go parallel. So to me, in a way, it's kind of similar logic in my brain is we have this adaptive threshold of rows. In this case, it's 85. If we need more than 85 rows, then we're going to go do a hash match. If it's lower than that, then we'll actually go ahead and do a seek. And that's what we kind of see here. All right, so with that, we have a demo. Oh, make that full screen. And hop back over there. And we'll say this is exactly what we showcased here. So once again, here's our coming in. Here we can see that the 223 is greater than our 13, and that's why we're going ahead and doing our scan here. So if we go over here to open a file, and I want to go and get another one here, adaptive join. Get those there. All right, so if we look at adaptive join here, go ahead and run another example for you. So here's just looking at some data from Wild World importers, showing our selectivity here. And in this example here, this is just showing you that if we are on before 2015 mode, or 2019, keep saying 2015, that's compatibility mode 2015 for SQL Server 2019. I turn on our execution plan here. So we see we only have one row. Let's do a nested loop. Very, very small. Makes perfect sense, right? So once again, if we pull out our execution plan, this is before 19 or 17. Here we see we're doing a hash match. So here, if we switch this back over, this is going to show you both sides here. So if we go after one single customer, this is going to be less than our threshold, and we're going to use a nested loop. So we only have one customer coming in here. So it's lower than our adaptive threshold, and because of that, we're doing that nested loop here, which when you look under here, we're going to see our seek, our rows, and data is coming from here. Where if we do more than one, it's going to beat our threshold in this demo. And because of that, remember the threshold here is 1.8, so one customer, two or more customers is going to have us actually use our hash match in this example.
So a question.
So here we can see.
Where does that threshold come from, or how's it derived? Do you know?
It's derived from cardinality from statistics.
In terms of, I mean, what do you know? What determines how they formulate what the actual number is, or is it more like query bucks where it's just kind of arbitrary?
No, I mean it's internal. It's built off of statistics from your execution class.
Got it.
I don't know of anything in particular released that gives some insight to the magic secret sauce of how that formula equates.
Okay.
But anyway.
You got a few more minutes. Good.
I know. Trying to wrap this up here. So we have here our 2 records. It's higher than 1, so we actually have our hash match, and here you can see the scan across the hash match. All right, so the very last demo here is going over memory reuse here. And so if this demo works, there's a little stored procedure here that's going to be executed. This will be our last demo to wrap things up. And so if we run this here, where there's no rows returned, and we look at our execution plan, we'll see here that we are granting a lot more memory than we actually use here for this. And so if we go ahead and run this guy multiple times, we run him first once by itself. So here we are going to return some data. So we built a plan off of very little data usage, because not much data was used in the filter over there. We'll see that this will take a while to run, and it will give us an execution plan here, hopefully with some spills. It's still running. Yeah, so we're using our plan there, which is, as we talked about in the very beginning, a plan is in memory. It's using that plan. It may not be the best plan for our set of data that we're filtering across. And because of that here, we're still doing our hash match. We're spilling the temp DB here. But the nice thing is if we rerun this a few times, we'll see that the memory usage will adjust. And you can see already that we now are using more memory that better fits, so we're no longer having to use temp DB to put data in there for a hash match and or sort. So with that, we're going to go ahead and wrap up here. So I hope you enjoyed this demo. We talked about a lot of really cool features in 19 and 17 that can help your code run faster without any code changes. It doesn't mean that you actually making code changes to identify the anti-pattern and correct the anti-pattern is better. There's a lot of cases where if you need the last inch of performance, that's still going to get you a lot of benefit. Regardless, here's the link to all the material that I have over SQL Server 2019. So videos, the demos, everything's right there. And then also, if anybody wants some help with free resources to help you with learning Azure SQL Database or migrating to Azure SQL Database, I have that link for you as well.